Hello, welcome everyone online. I'm Monica from ESA Education.
And I'm Fergus from the Raspberry Pi Foundation, and we are your hosts for the ESA Education Astronaut Q&A for 2025.
Yes, and we are very happy to be here today to celebrate all the amazing projects made by teams from Astro Pi, Mission Space Lab, and MoonCamp this school year.
Let us know where you are joining from, your team name, and which project you took part in on the chat. We're going to do some shout outs in a couple of minutes. Monica, could you tell us a bit more about the two projects?
Sure. Teams from the MoonCamp Challenge have submitted amazing habitat designs on the moon and beyond. And all the Astro Pi Mission Space Lab teams have created some incredible code in Python to gather data to calculate the speed of the ISS.
Fantastic. Well, a huge well done to everyone joining us for the live stream today. It's a truly great achievement, and we hope you had fun taking part in the projects. So, Monica, how many teams took part in MoonCamp this year?
We are very happy that 1,253 teams took part in MoonCamp so far this year. So massive congratulations to everyone who took part, and also many thanks to our partners at the Airbus Foundation. And what about Mission Space Lab, Fergus?
552 teams took part in Mission Space Lab this year, and 309 teams achieved flight status. They had their code run, they had their computer programs run on the Astro Pi computers on board the International Space Station. How cool is that?
Oh, it's very cool. So well done to everyone. Shall we see which teams have joined us today?
Yes, let's see who we have on the chat. So we have lots of people joining today. We have, let's see, Marda Mary, hello from Romania. Thank you for joining us.
Let's see then. Hello from Portugal. Hello to Paulo Inácio from Portugal.
And we also have Anna Apitra Pridirmanovi. Hello from the Czech Republic. Welcome to the live stream.
And hello from Dan. So hi Dan, welcome you, and thanks for joining.
Thanks for joining the session today, everybody, and also for sending in your questions as well. But first, before we get into the questions, Monica, I believe we have a very special guest joining us today.
That's right. We are very, very excited to have ESA astronaut Luca Parmitano joining us today. He has been an astronaut since 2009 and also the Astro Pi ambassador 5 years ago.
I can't wait to meet Luca. Shall we do a little drum roll to welcome him in?
Yes, let's do it.
Okay, everybody, hands on desks. Here we go.
Please give a warm welcome to Luca Parmitano.
Hello everybody. Thank you for having me. It's great to be here.
Hello, Luca. Welcome to the live stream, and thank you for joining us today. We know astronauts have very busy schedules even when they're not in space, and we're curious to hear, where are you calling from today?
So despite my background, which is the Gorner Glacier in Switzerland, that's not where I am. Unfortunately, I wish I was there. I'm in a much hotter place. I'm in Florida at the Kennedy Space Center, waiting to see when we will launch the next ESA mission called Ignis with the crew of Axiom 4 and our ESA project astronaut, Sławomir Szuznaki from Poland. I'm here to support the launch, and I wish I could show you the rocket in the background, but I'm currently not outside, so this is the best I could give you.
Amazing. And Luca, I don't know if you know, but Slavos Znansky, the project astronaut from ESA, was the ambassador for Astro Pi this year, in fact. So it's great to hear that he's going to be going up to the ISS soon. So fingers crossed for the takeoff and that it's not too delayed. Well, thank you for taking the time out of your busy schedule today, Luca. We are so pleased to have you here today. It's not every day that you get to meet and ask questions to someone who has actually been into space. And we have 20 questions from Astro Pi and Moon Camp Challenge teams for you today. Are you ready for some questions from the teams?
Let's do it. Let's launch.
Fantastic.
Yes, so let's go. I think we can play our first question.
Hello everybody, we are secondary students from Massanassa, Valencia. My name is Camino.
My name is Lucia. My name is Merce.
My name is Sofia.
My name is Nico.
My name is Juan.
My name is Rodrigo.
My name is Carlos.
And we are doing a Massanassa project. And our question for you is, what do you like most about being an astronaut? Thank you. Bye.
Bye.
So that was Team Galactic from Spain, and they were asking what you like most about being an astronaut.
So I almost never put things in a ranking because because I always change my mind all the time. So today I like one thing, tomorrow I'm gonna like another things. Right now, what I like most about being an astronaut is the fact that I can have a very, very easy approach to all the things that I'm curious about. When you are an astronaut, you are not just curious about space and space flight. You're curious about science, technology, education, inspiration, Earth observation. You're curious about everything. I mean, you're just universally curious, just like kids. And so being an astronaut allows me to have access to a lot of different aspects of this culture. So sometimes I'm interacting with students and I'm learning about new things that happen that I'm not aware of. Sometimes I interact with Nobel Prize and I can understand a fantastic new discovery or piece of technology that's going to change the world. Sometimes I get to go to space, which is really a fantastic perk. I spent 366 days in space, and it could have never happened if I wasn't an astronaut. And so really this variety, the fact that it's an ever-changing job, I never have the same schedule from day to day. My days are always different. I'm always doing different things. Sometimes I go underground, sometimes I go underwater, sometimes I fly in airplanes and helicopters. So really this variety is what really attracts me. And I think is one of the things about being an astronaut that are really worth investing for. So I would say that today, the fact that I have so much access to all these different things is one of my favorite parts.
Wow, yes, that seems very exciting, but also very challenging. So yeah, thank you for your answer. And I think we can go with our next question.
Hi, we are Samuel and Diego from Team Forsor of the Field of Castillos, Alcorcón, Spain, and we are going to present you our question.
What has been your academic and professional career in order to get here? Thank you very much. Bye-bye.
So from Team Forsor in Spain are asking, what was your academic and professional career path been like to get where you are now?
So I get this question a lot. When I was in high school in Italy, I went to what is called a scientific high school. It's a 5 years high school course profile. One of two typical ones. One is the classical, one is the scientific. I picked the scientific school. With a small delta, I actually was an exchange student abroad for 1 year. I went to the United States as an exchange student by myself for 1 year, and then I came back. I finished high school, and I entered the Air Force Academy. At the Air Force Academy, I did two course of studies at the same time. On one side, I was studying aeronautical sciences with the Italian Air Force Academy, and then next to it, I was also studying political sciences with the University of Naples, Federico II. So After I finished the academy and the university, I went to flight school. I became a fighter pilot, and I was an operational fighter pilot for about 7 years. In 2007, I was selected by the Italian Air Force to become a test pilot, an experimental test pilot. What that means is that I qualified after 1 year in school. I qualified to fly airplanes and systems that have never flown before. So every time something new comes up that needs to fly, whether it's a helicopter or a new aircraft, or whether it's a system, so a new engine, a new radar, a new navigation system, there has to be one person that is the first one to fly that system, that aircraft, and those are the test pilots, experimental test pilots. And that qualification is actually very important, because every space flight is a test flight. There are no two flights that are the same in space, and so a lot of the early astronauts were test pilots, and that's how I became an astronaut, by being an experimental test pilot. However, this is important. I want to add this thing. This is just one path to become an astronaut. Nowadays, you can be a scientist, you can be an engineer, you can be a doctor, you can be a pilot, and maybe in the future there will be also other paths to become an astronaut. So you don't have to be a military pilot, you don't have to be a test pilot. Please go ahead and do it if that's what you love, is that what you like. But what we're looking for is people that are really good at what they do. And in order to be really good at what you do, you have to love what you do. So be the best at what you like, be the best in your career, and then if you want to become an astronaut, you'll have a chance to be one.
Thanks, Luca. What a brilliant message to end that answer on as well. And I think you must be incredibly brave to be a experimental test pilot as well, to do that kind of work. So hats off to you. Great stuff. Let's play the next question.
Hi, Luca. We are Team Astrovel from Toronto.
We are so excited to talk to a real astronaut like you.
We've learned that being an astronaut is not easy.
So we are going to ask this question.
What personal skills and qualities do you think are most important for being a good astronaut?
So this was Team Astrovel from Canada, and I think it connects very well with what we were saying. So what personal skills and qualities do you think are the most important for being a good astronaut?
So I actually will go back to my first question. I think that what you really need to be is curious. If you want to learn, if you are curious about learning new things, different things that are not part of your own background and experience, then you already have one characteristic to be a good astronaut: curiosity, the drive to learn new things, to put yourself in a place out of your comfort zone. I always say that the first thing I do in the morning, the most important thing in the morning, is to get out of bed as soon as you can, because it means that you are ready, you want to learn more things, you are ready to start your day, and that kind of enthusiasm, that kind of desire to engage yourself, to challenge yourself, starts in the morning when you get out of the comfort of your bed into the world. So if that's the kind of personality that you have, if that's the kind of thing that you want, you already have it. And then in terms of personal skills, where we teach you those skills. We teach you how to be a good scientist, a good engineer, a good pilot, a good astronaut. That's part of our job. I'm an instructor now after many years being an astronaut. And so what we want you to be is to be curious and to have those interpersonal skills. So because you're going to spend a lot of time with your crew, we want you to be a good person. We want you to be a person that listens, that knows how to lead, but also knows how to follow. We call those soft skills, and you learn those things with life, like throwing yourself into different experiences and listening to people, learning in school, learning in college, by being observant, and overall just being a good person. Imagine that if you're going to be confined in a small place with always the same people, you want those people to be your good friends. You want to have fun together. You want to be understanding of each other and just good person. So two different sides: the personal skills, the interpersonal skills, those you bring in, and then the technical skills, we teach those to you.
Wow, thank you so much. But that's good news, because I'm sure all the kids following are already curious just being here today. So we're on the right path. And thank you. And I think we can go with the next question.
Hello, this is Auckland Junior School's question for you.
What speed do you have to go to break through the atmosphere without burning up?
And what effect does it have on your body? Thank you for listening.
Bye!
Thank you. So that's Team Oella from the United Kingdom, and their question is, what speed do you have to go to break through the atmosphere, and what effect does it have on your body?
This is, first of all, they were really fun to listen to, so cute. And then the answer is actually very, very simple. There is one speed, which is called the first cosmic speed, and it's the speed that you need to have in order to go around the Earth and stay in orbit. That speed is 8 kilometers per second, or 20,000 kilometers an hour. And what does it out? Because you are from the UK, you probably also use miles per hour, so I'm going to translate that. It's 5 miles per second, or 17,500 miles per hour. When you're launched, our bodies don't experience speed. It's like when you're on the train. It doesn't make a difference whether the train is going at 10 kilometers an hour or 300 kilometers an hour. Speed, we don't feel speed. What we do feel is acceleration. And so when you're launched, when you're sitting on the rocket and you're being launched, you are experiencing an acceleration. Just like when you're on the roller coaster or when the airplane is taking off, we feel the acceleration. Now that one is a lot of fun because the rocket launching you to space is the biggest roller coaster ever. It takes you to about 4.5 Gs, which means you feel your own body weight times 4.5 times. So your arms weigh 5 times more, your head, your body, your chest. It feels like a giant hand is pressing onto you. I think it's a lot of fun. I love it. And I think that if you try that experience, you will love it too.
Amazing. Thank you for that insight. Not many people will have experienced that kind of acceleration, like you say. Thanks, Luca. Okay, let's have our next question.
Good evening, Mr. Parmitano. Welcome to Greece. I'm Konstantinos.
Welcome to the Germanic ESA Observatory. We have a question for you. I am Nick Howard.
How did you feel when you saw the Earth for the first time from above? I am Theodoris.
Greetings from DJ Astronauts.
Love the video. So
Yeah.
It was Team DJ Astronaut from Greece, and they're asking, how did you feel the first time you saw the Earth from above?
I am really enjoying these videos, the creativity behind it and the locations with the telescope and the multimedia, really, really cool. So this is actually one of the toughest questions to answer. It is really tough because there are no words for it. And let me expand a little bit. I will spend 1 minute explaining what I mean. When we use languages, when language is developed with humanity, they either describe things that we feel, that we see, or that we think of, but that we imagine. Even dreams. We have words for dreams, we have words for things that we imagine, but we don't have words for something like seeing the Earth from space. We just don't. It's an experience that it goes beyond any of those three events. It's beyond what we experience, it's beyond what we can imagine. So I wish, personally, that we could send a poet like Antoine de Saint-Exupéry, who wrote The Little Prince, because he had the kind of spirit and experience to invent the words to describe this kind of sensation. However, every time I go see the ocean or the sea, the Mediterranean Sea, it's a little bit like that, where it's at the same time all these different emotions. You see the expanse of the blue, You smell the breeze. You feel it on your skin. You feel the sand under your feet. It encompasses you completely as a person. Seeing Earth from space is a little bit like that. You see in front of you, you have your past, your present, and your future, and everything that you love in front of you. You are 400 kilometers away, but you're not disconnected. You are really, really connected because you see how fragile, how important, how beautiful it is. And in that moment, really, more than any other time, I think, you realize how important it is to protect it, to keep it safe, and to make sure that the future generations will have it as beautiful as it is.
Wow, Luca, I think you can be a poet because you made us live it a little bit with you. So thank you. And I think we can go with our next question.
My name is Robin. During the Beyond mission, you controlled an Earth-based rover from the ESA in the Analog 1 experiment. How was it possible to control the rover from such a huge distance away? Thank you. Bye.
So Luca, this is from Team Dimash-Forscher 3001 from Germany, and their question is, during the Beyond mission, you controlled an Earth-based rover from the ISS in the Analog 1 experiment. How was it possible to control the rover from such a huge distance away?
It was so cool. It was really, really, really cool. So, the space station is flying around the Earth, and above the space station, so the space station is only 400 kilometers away, but above the space station, we have satellites at different altitudes. Around 20,000 kilometers from space, and then again at 36,000 kilometers, we have different satellites that rotate, and they are able to relay messages from one place to another. They cover the entire Earth, and they are able to take a signal from the Earth, send it to the space station, and then it bounces off another satellite and it goes back. So I was on the space station, and I could see images on the ground from the rover. And then I have an interface just like a video game where I could pilot the little rover using the hand controllers, and I could see what the rover was seeing with a very small delay, maybe 1 or 2 seconds. So if you know that, you can adjust your controlling, your commanding, so that you can respond to the little bit of delay that is on the ground. And then you move the controllers, and after 1 second, the rover responds, and you see it on the space station. So it's a little bit, to me, on orbit, it was like moving a video game, controlling a little rover in a video game. But the beauty of it was that instead of being a video game, it was an actual rover on the ground. And one day, the idea is that maybe we are around Mars, for example. And before we land on Mars, we are going to have a rover on Mars. And if I want to install an antenna, I can drive the rover, pick the perfect spot, and then have the rover lay the antenna. Or if I want to pick up a rock, I can find the right rock, I can point at it, and then I move my commands and grab the rock, put it away so that I save it. And that was the experiment, and it went really well, and it was really a lot of fun.
That sounds amazing. And like you say, great kind of testing for future uses on places like Mars and the moon, I suppose, as well. Thank you, Luca. Okay, let's play our next question.
Hello from Finland. We are already on summer holiday.
Our question is, what is a typical day like for an astronaut on the ISS?
So this was team HYRYSY from Finland, and they're asking what is a typical day like for an astronaut on the ISS.
First of all, I want to know what all those Ys mean, but why is a good, why is a good question. So I'm just curious. Maybe one day they will answer. I understand that they are on vacation already. Good for you. So the beauty of my job is that you never have the same day. So every day is different on the International Space Station. Some days you do a lot of science, some days you do a lot of logistics, some days you do spacewalks. However, on average, this is how it works. You wake up around 6:30, and then just like on Earth, you go and take care of yourself. You go to the toilet, you shave. I have to shave a lot. Then you have breakfast, and then around 7:30, we have the first radio call to the ground. We call first Houston, then we call Huntsville, which is Houston is the main mission control center, the one that answers, Houston, we have a problem. They're the ones that answer. Then we call Huntsville, which is the mission control center for all the experiments. Then we call Munich. Munich is the European mission control center, and they're responsible for the European experiments and European systems. Then we call Tsukuba, which is the Japanese center. Then they're responsible for the Kibo module and Japanese experiments. And then finally we call SOUP. The SOUP is not a soup. It's the mission control center for our Russian counterparts. And then after we make these calls, our day starts. So it's around 8 o'clock, and from 8 until 7 o'clock, we just work. We do a lot of science. That's our main mission, is to do experiments. All kinds of experiments, from physics to biology, to physiology, to medical experiments, to material experiments, or material science, fluidics, you name it, we have probably done it. And then the second job that we do is logistics. The space station is an actual station. We have spacecraft that come, spacecraft that go. We have experiments that come up for the first time. We take them and we install them, and then we take the old stuff and we put it back in the spacecraft, and all this transfer has to be done by us. And then the third job is really important, is physical exercise. 2.5 hours every day, the astronauts have to work out. We have 3 machines on the space station, or three, depending if you're Italian or not. And we use these machines to lift weights, which is amazing because we are in a weightless environment, but we have a machine that allows us to do the same exercises of weightlifting. We have a running treadmill, so we can run, but we have to wear a harness, otherwise we would bounce off. And then we have a bicycle machine, which is interesting because it only has the pedals. It doesn't have a seat, it doesn't have handles, but we just float and we attach our feet and we pedal. And we have to do that 2.5 hours every day, because otherwise our physical fitness would go down really, really fast. And then there are special days where we have to do robotic activities. For example, capturing a spacecraft that arrives with the Canadian robotic arm called Canadarm2. We capture it, then we install it, and then it's really fun. It's like flying in 3D with this robotic arm. And the last but not least of the special experiences are called EVA, extravehicular activities, also known as spacewalks. Spacewalks are a lot of fun, but also a lot of work. I have done 6 myself. I have helped other astronauts do many of their spacewalks, and those usually take whole day. So again, we don't have a typical day on the space station, but in general, around 7 o'clock, we finish our day, we have dinner, and then we call one more time on the ground to make sure that everything is done. We don't have any special news or conditions. And then after that, we can rest, we can relax, we can call our family maybe, or we can just relax and talk among ourselves.
Wow, it looks like a really busy day, but everything's super interesting. Yeah. Thank you, and let's go with the next question.
Hello from the 3rd Secondary School in Thessaloniki, Greece.
And greetings from our moon camp team.
We have been working on moon habitats, space science, and astronaut training.
Learning about space inspires us to imagine living beyond the Earth.
So, our question is,
do you think differently when you are space? Thank you, Luca! Greetings from Earth!
Buon viaggio!
Ciao!
Fantastic video. Luca, do you dream differently when you are in space? From Team Moon Camp from Greece.
That was really fun. So this is a tough question, because I'm one of those people that don't really remember their dreams at night. I'm so sorry. I just don't. I wake up in the morning, and like I said, I jump out of bed, I'm gone. And if I had a dream, I forget it within instants. And so I'm not very good at remembering dreams. I remember very few of the dreams, but I cannot tell you if they're different or not, because I dream about all sorts of things. My dreams are always different. Sometimes I dream I'm in space when I'm on the ground. Sometimes I think I'm in space when I'm in space. Sometimes I dream about being on the ground when I'm in space, and vice versa. So dreams are dreams. They're just strange. You know, it's your brain doing your dreaming thing. So I don't know. I don't think my dreams were anything different when I was in space. However, I will tell you one thing that's really different. Right before falling asleep, there is one phenomenon that's really interesting. When we are above the atmosphere, sometimes we have stray photons that are flying around, and normally on the ground they get absorbed by the atmosphere, so you don't even notice them. But when you're in orbit and you're just about to fall asleep, so you're almost asleep but your eyes are closed, and then a photon just goes through, it hits one of your eye cells, and you see a flash, but there's nothing. It's just a little beam of light hitting your eye, and so you're falling asleep and you see this flash, and it's like, whoa, what is that? And another thing that's funny is when you wake up the next morning, and because you're in microgravity, we don't have a bed, we don't have a pillow, we don't have a blanket, we are just in our sleeping bed, and our arms are outside and are floating in front of you. So the first thing that you see when you wake up is your arms. And unless you remember that you're in space, it's like, whoa, whose hands are these? And they are your own hands. And it gets a little bit of getting used to it.
Amazing. Thank you. The photons going through your eye sounds totally crazy, but thank you for sharing that. Okay, let's play our next question.
Hi, we represent Artemis team at Sakio Middle School of Patras. We are working on a moon camp project for students.
We would like to ask you to suggest a chemistry experiment that would be performed under microgravity conditions.
This was Team Artemis from Greece, and they're asking your suggestion for a chemistry experiment that could be performed under microgravity conditions.
So, I've done a lot of experiments, and a lot of them are to do with chemistry. So there is one that is a lot of fun, but I don't know if it's good for students, and it's actually about burning things in space. When you burn something on the ground, let's say you turn a candle on, and everybody knows what a flame looks like. It starts small, then it goes up, and then it goes really, really thin and becomes tear-shaped or shaped like a flame. However, that is due to the fact that on the ground, because of gravity, the density of all the different things affect how they move, and so the lighter things tend to go up, and that determines the shape of the flame. It's because the gases that are lighter than air tend to go up, and they determine the shape. In space, the difference in density does not affect motion because there is nothing pulling them up or down. So flames are actually spherical, and they're really interesting to see. They behave differently. As a matter of fact, we found out that when something burns, there are two stages of the flame. There is a hot stage, and then there's a colder stage of the flame. And the shapes, again, are really circular. They're really different, and so it's quite unique. So that is an experiment. That is a chemistry experiment. That the transformation really is affected by what's happening in orbit. Another experiment that may be easier is a simple mixing experiment. If you take two liquids of different density and you mix them on the ground and you put them on a table, if you mix oil and water and you put it on a table, initially they will be all mixed together. There will be droplets here and there. Maybe you don't even see the droplets. It becomes an emulsion. And then after a few hours, because of the density and the gravity, they will separate again. So nothing stays that way forever on the ground. It eventually separates because of gravity. But in orbit, if you mix them all together and leave it there, it's going to stay like that because there is really nothing trying to move them around, or maybe just the molecular motion moves them around, and then things touch each other and become bigger, and then they become bigger and bigger, and eventually maybe they separate again. But it will not be two different, they will not be separated in strata. It will be just mixed together some different way. So that's a very interesting physical, chemical experiment to see in microgravity.
Yeah, thank you for sharing. That's also an easy experiment we can for sure do at school or at home. So thank you. And yes, let's go with our next question.
Hello, I'm Justin. And I'm Raul. And we represent Team Asterix from Romania. We are happy to have reached this stage in this contest.
Our question for the ESA astronauts is, has something strange ever happened in space that you couldn't explain?
So this is a question from Team Astro X from Romania, and they ask, has something strange happened in space that you couldn't explain, Luca?
So we have had, in my personal career, we have had a few things that we couldn't explain at the beginning, but then in the end, we always found an explanation. So sometimes people ask me about UFOs or aliens or things that cannot be explained. I have not experienced anything of the sort, either as a pilot, as a fighter pilot, as a test pilot, or as an astronaut. I had never seen anything that I couldn't explain, or even though I couldn't explain it right away, didn't have an explanation later. One thing that really surprised us one day was that we were flying over Europe, and all at once we saw a launch. We saw something coming up the atmosphere, straight into the atmosphere, into space, and we were like, what is that? Because usually they tell us if there is a launch, if there is something that we can take a picture of or observe, because it's really fun. But we didn't know anything about it. So I saw this launch happening. I called my colleagues, everybody came, and then we saw this object coming to orbit, and then it separated, and then it created this big plume. And it was a test launch that nobody knew about. Maybe it was, I think it might have been a military launch. But it was really cool to see, and we just were not surprised until the next day when they told us that it was a test of a rocket. Another thing that we saw one day was that we saw a little piece of a cover, something that was floating around the space station, and we had no idea how, what is it and why is it floating around the space station. And then we found out that during a previous space from our Russian colleagues. They had been manipulating a cover, and this cover had come undone later on, and so it just floated away, and then it disintegrated. So those are really the only things that happened or that I can remember. But again, nothing that we couldn't explain.
Fantastic, thank you. Okay, next question, please.
Greetings from Bucharest.
We are honored to have the opportunity to ask a question to Mr. Luca Parmitano.
We would like to ask you, how is the effect of radiation on electronic systems on board the ISS monitored in real time, and what happens when a component starts to degrade?
Thank you so much, and we are looking forward to your answer.
So this was Team CDP Vianu from Romania. They're asking, how do you monitor real-time the effect of radiation on electronic systems on board the ISS, and what happens when a component starts to degrade?
You can tell that these students were a little older because this is a very technical question, and unfortunately, I have to give a very technical answer. So there are many ways that we can do this, that we can monitor when radiation affects the computing capability of any system. So let's take, for example, a computer. A computer is constantly doing its job, and then if some radiation hits a 1 and it turns it into a 0, all at once, those computations are completely different. But if you have 2 computers, or even better, if you have 3 computers, you can constantly compare the computation. You put the same data, and the results should be the same. Now, if it's really unlikely that you have the same change hit at the same time on 2 computers. So what we do is that we take 3 computers and we compare the values, and if there is a difference, we take the value of the 2 computers versus the one on the single computer, because we believe that if there is a mistake, it's done by the single computer that maybe was hit by radiation, and we had a flip, again, a 0 becoming 1 or a 1 becoming a 0. So that is one thing that we can do. Another thing that we can do is to make the computation twice. So we run a computation in a certain amount of time, and then we do it again. And we make sure that the result is the same. And if it's not, now we know that there's one of the two results is wrong. And we can just discard that result, and we can ask the computer to do it again. And it depends on the system. If it's a very important system, then we use three different ones. If it's not so important, then we can intervene from the ground. We just put one of those systems in place where, again, we run the computation twice. If we get two different results, something is wrong. And then another thing that we do sometimes, if it's a system that is not essential, it's just doing routine operations, we can have the system simply shut down. It senses that something is wrong because it's supposed to be doing always the same action. And if all at once the instruction changes, the system understands that something went wrong and it shuts down. So those are typical ways how we take care of radiation hitting automatic systems.
Thank you. It was technical, but you explained it very clearly. So thank you so much. I feel we are all learning today. So thank you. And let's go with our next question.
I'm Lorenzo from MenSub team from Italy. And my question is, how does it feel to go on a spacewalk?
Okay, this is from Team MindHub from Italy, and they're asking, how does it feel to go on a spacewalk? And Luca, I'm sorry to have to rush you, but we are a little behind. So if I can get you to try and answer this in 2 minutes, which is probably very difficult, I would really appreciate.
I'm going to try to be really fast. So again, if you remember my first answer about being in space and watching Earth, it's a little bit like that. Only the difference this time is, if you've ever been in the water swimming and you see the tropical fish and everything underneath you, and you look at the corals and the fish and everything that's happening, but you're just either floating with a mask and you are, or maybe you're on one of those boats with the transparent bottom, and you're just observing it. And the difference with a spacewalk is that, imagine now you put your scuba gear on and you jump into the element. What you're seeing is still the same. You're still seeing the same fish. You're seeing the same corals, but now you are into it. You are immersed in the same environment. You are an alien into this very, very lively, incredible environment. So a spacewalk is a little bit like that. When you're on the space station, you're looking outside. It's like looking at the most beautiful aquarium. But if you could jump into the water with a scuba gear and now move around the aquarium, that is the equivalent of doing a spacewalk.
Amazing. A great analogy. Thank you. Okay, let's play our next question.
Hi, from Space Education Center. We have a question. Which moments were the scariest or least frightening during your space missions? How did you manage to overcome your fear? And do you think these methods are useful for everyone to learn?
Wow, this was a super cool video. I think the question is clear. So which were the scariest moments during your space missions, and how do you prepare to overcome fear?
So let's answer the second question first. To me, there is only one definition of fear. Fear is having to deal with something you don't know. No matter what it is. When we are kids, we are afraid to go into a dark room because we don't know what's inside the room. We open the door. Is there a monster? Is there a hole? Is there an obstacle? We don't want to go into a dark room because we don't see and we don't know what's out there. But if we could turn on the light, now everything changes. You turn on the light and now you can see the hole, you can see the obstacle, you can see a monster. And it doesn't matter because now we know what to do. It's not fear anymore, it's making that decision. We have to act onto something. If there's a hole, I'm not afraid of falling into the hole. I just go around. If there's an obstacle, I'm not afraid of the obstacle. I just have to jump. If there is a monster, I just close the door. So fear is not knowing. So the opposite of fear is knowledge. Astronauts train all the time, constantly training, studying, learning new things, because the more we know, the less we are afraid, because there are few things that we don't know. When we launch, we know our system. When we land, we know our systems. When we go outside on a spacewalk, we know our systems. We have studied, we know them, we know how to use them, we know what's out there, we know how to operate them. So I had a very, very dangerous emergency during my second spacewalk. This was, it happened on me. I was outside of the space station in my spacesuit, and I had a malfunction that started filling my helmet with water. And even though we had never trained for it, I knew my systems. I knew the space station. I knew how to get back. So again, for you, this is a wonderful question, and I think it's a wonderful lesson. Knowledge is the antidote to every fear. If you know, the more you know, the less you will be afraid.
Yeah, thank you. I think that's super important for all of us, actually. So thank you. And yeah, let's play our next question.
Hi, Luca. I'm Christina.
And I'm Elina. You have been on 2 ESS space missions several years apart.
We would like to know if you noticed any significant differences regarding the ESS and/or Earth when comparing your first and second mission.
Okay, over to you, Luca. I think that was pretty clear. So
yeah, absolutely. So the ISS did change in between missions. So sometimes we add new modules. So in my case, that wasn't what happened, but we moved one big module and we put it somewhere else. So the shape of the space station was different. Also, we had a lot more traffic. We had a lot of different cargo spacecraft coming up that we didn't have on the first mission. So that was a difference. The biggest difference was me, because on the first mission, I was a rookie. On the second mission, I was a commander. So the responsibilities and the way I approached the work was completely different. The last one about the Earth, there is actually something that's really important for you guys. I saw the differences brought by climate change and human activities. Specifically, I saw some climatic events that were really, really egregious. We saw one storm that was one of the worst storm ever recorded in the history of mankind. It was called Hurricane Dorian. I also saw a lot of fires in the forest, in the Amazon forests. I saw a lot of the Amazon forest becoming cultivated fields. So, unfortunately, the changes on the Earth were really noticeable, and none of them were really good. So, once again, this is our only planet, and we need, once you see it and you see how important it is, you really want to do anything you can to protect it.
thank you, and that's a very powerful message. Let's play our next.
I'm Amalia.
I'm Laura, and we're the cast of Stellar Nights.
We did the Moon Camp Challenge, and we have a very important question for you.
What was your first thought when you landed back on Earth after your missions?
I love these videos. They are super fun and very creative, and the kids are just amazing. So that said, my first thought is, wow, I am really heavy. I think that is a common thought for everybody, because after 6 months on the space station, you forget what being heavy feels like. You forget that you have a head on top of your neck. You forget that you have a head and neck on top of your torso. You forget that you have a torso on top of your legs. So all at once, you forget. You know, I was 80 kilos, and I didn't know what it felt like to be 80 kilos. And then I stood up, and I'm like, whoa, I am so heavy. And so for the first couple of weeks, laying down is really good. Sitting is okay, and standing up, it's really hard. So I think that was my first thought. It was like, wow, I'm really heavy.
That's a nice thing to realize after some months. Thank you. And yeah, let's go with our next question.
Hi, this is Space Y. My name is Jakub.
And I'm Conrad. Our question for you is, does being in space change the way you perceive time, days, weeks, or the future?
And I think Fergus is muted.
I put myself on mute. I told everybody not to, and then I did it myself. Terrible mistake. Excuse me. So Team Space Y from Poland, and their question was, does being in space change the way you perceive time in terms of days, weeks, or the future?
So is that different from what's underneath on the, because if it's Team Primus, he says, how do you think space travel will be revolutionized by AI?
Yes, it's so let's put Team 15. Here we go.
Okay. So it really doesn't, because we actually use the same time system that we have on the Earth. We put our watches and our clocks and everything on Greenwich Mean Time. So we wake up at 6:30 Greenwich Mean Time. We have a 24-hour day, and then we go to sleep around 11 to midnight. So the perception on space of time doesn't really change. However, most astronauts, I think there's one astronaut that is currently in orbit, her name is Anne McClain, that really described well what happens in terms of how we feel. She said, days are long and weeks are short. And what she meant by that is that during the day, we are so busy. Like I said before, we have a lot to do. We wake up at 7 o'clock and then we go to bed at 11 o'clock. We work for 12 hours a day. We are really busy. But then you look back 1 second and it's been a week. And then it's been 2 months. And then it's almost time to get back. And you think, I was supposed to be 7 months, and you went in the blink of an eye. So that's the best answer I can give, I think, is the one from Anne McClain. The days are long, but the weeks are short.
Brilliant. Thank you, Luca. Okay, let's go to our next question.
Hi, this is Space Y. My name is Jakub.
Hi, we're from Team Primus, and our question is, how will space travel be revolutionized by AI and robotics?
Okay, here was Team Primus. So how do you think space travel will be revolutionized by AI and robotics?
So, to be honest, it's already been revolutionized. Space is one of the first environments that ever used artificial intelligence. Already back in the Voyager, there were some little characteristic, little computation algorithms that are the basis of what today we call artificial intelligence. I think that in the far future, when we travel at interplanetary level, so when we leave planet Earth and the moon system to go towards Mars or beyond, we are going to need artificial intelligence to really take care of our spacecraft, because humans will not be able to take care of all the different systems that are necessary for a spacecraft. So we are going to need very advanced artificial intelligence to find out the problem and also fix the problem, and also fix itself if it has problems, like I was saying before. So this is how space travel is going to be revolutionized. It will need to drive our spacecraft for us.
Wow, that's true. Thank you. Let's go with our next question.
Hello everyone, I'm Walter Chow from Yoli River team. My question is, what do you think is the most important factor, including material and spiritual factors, for long-term life in outer space?
Okay, so just to repeat the question for you, Luca, this is from Team Luili River in China. And if we can keep it quite short, maybe in one sentence, what do you think is the most important factor for long-term life in outer space, including material and spiritual factors? There's a lot to pack in.
Yeah. So for materials, it's going to have to be something very durable. We are going to have to invent materials that can withstand extreme temperature changes from minus 150 to plus 150 because of the difference from daytime and nighttime. But also, again, things that can fix themselves. That's an easy answer. The spiritual one, that is going to depend very much on the individual, but I think that those who choose to have this kind of experience are pushed by motivation that's inside them. It's really just a desire to explore and to put yourself out there. So I think that they will have to find it within themselves.
Amazing. Thank you, Luca. Okay, let's play our next question. And this is...
Hello, Mr. Parmitano from Castle in the UK. How do you think space exploration could benefit people back on Earth in the future?
That was very sweet and also very clear. So I leave it to you, Luca.
Oh, my gosh, so sweet. I think it does all the time. We have thousands and thousands of scientific data and results that come back to Earth after every mission that contribute to our knowledge of our planet, our universe, and ourselves. We can use that data, and we use that data for medical advances, technological advances, and our understanding of where we are and how we got here and where we are going. All of these things are equally important. I believe that the betterment of humankind depends both on our physical well-being, and that is driven by technological advances and medical advances and material advances, but also our knowledge, our understanding. And it's just as important to nurture our mind as it is to nurture our bodies and well-being. So I will give you just one example of technology that exists because of space. Every time you walk into a public building, you will see a small box, usually yellow, with 3 letters, AED. It means automatic electronic defibrillators, and it's a system that if somebody has a heart attack in the middle of the public space, anybody can reach out, put those electrodes, and revive them, save the person's life. And it was developed because of humans flying in space. So that is just one example out of thousands and thousands of technology that exists thanks to spaceflight, including the capability to make this conversation while I'm in Florida and you are all over the world. So I hope that answers your question. There are many, many, many ways.
Yes, thank you so much, Luca. Thank you.
So that's all of the questions that teams have recorded for you today, Luca. A big thank you to all of the teams that sent in their questions. We absolutely loved your videos.
Yeah, thank you so much. We received so many that we only had time to select for this one selected. So now we are unfortunately gonna have to say goodbye to Luca. So thank you again for joining us today and answering all these questions.
It was a pleasure. Thank you for having me. Thank you to all the kids for their wonderful questions.
Thank you, Luca.
Yes.
Bye-bye.
Bye. Thank you.
So Monica, I guess that's all for this year. All we have for this year's Astro Pi and Moon Camp challenges.
Actually, Astro Pi has finished for this academic year, while submissions for Moon Camp are still open. So if you haven't had the chance to send out your design yet, you can still do it. And it's been incredible to see all the creativity and hard work you put into both these challenges. With Moon Camp, you stepped into the shoes of real space architects and habitat designers. And with Astro Pi, we are sure you developed coding skills that are key to shaping the future. So well done to all of you who took part.
Yes, massive congratulations to all of you for all of your successes with this year's challenges. Also, please share your projects on social media with us if you're able and comfortable to do so. Your Moon Camp designs or any analysis you do with your Mission Space Lab data from the ISS. You can connect with us on X, Facebook, and Instagram using the tags @ESA and @AstroPi, @Astro_Pi, I should say.
That's right. And if you enjoyed doing the activities this year, why not to try Astro Pi and Moon Camp also next year?
Yes, both challenges will be back in September, so stay tuned for exciting updates about next year's editions. You can catch up on this live stream on YouTube And if you were not watching live, then thanks for taking the time to watch the recording. Finally, we'd like to say a big thank you to Richard, Nina, and David, who have been working behind the scenes to run this live stream. And Monica, thanks again for hosting this webinar. It was such a privilege to meet Luca, wasn't it?
Yeah, definitely. But also it has been great fun. So thanks everyone for coming today. And I'd say we look forward to seeing you again very soon. So goodbye.
Goodbye.
Ciao.